All right, now we're on to lesson 12.6. 12.6 is permutations and combinations. Now, this might get a little confusing, but don't worry. You can come to class and we can explain it in more depth. A permutation, so write this down, is an arrangement in which order is important. So I want every single one of my things to be ordered a different way. So if I have the letters O, P, S, and T, how many different ways can I put them? So you use the counting principle to find the number of possible permutations. So here's an example. I have 4 letters. Find the number of permutations possible for the letters O, P, S, and T. I have 4 options for my first choice. For my first letter, I have 4 options. Once I place a letter, I'm only left with 3, and then 2, and then 1. So my total permutations would be 4 times 3, which is 12, times 2, which is 24, times 1. So 24 is my total. Okay, so here's how it's written. A track team has 7 members. In how many ways could 4 team members line up for a relay race? So you can use permutation notation to represent this problem. 7 members, choose 4. Okay, so this is what it looks like. There's a large P, and then the 7 members goes first, and then the 4 goes second. So it looks kind of funny, but it's really simple. So what you do is you start with the first number, and you do 7, and you're going to fill 4 spaces with every number that comes after 7, or actually before 7. So it'll be 7 times 6 times 5 times 4, which is 840. So here's a couple examples. These should help you. Simplify each expression. 5 permutations of 2. So what this means is I have 5 people and I want to put them in 2. I want to choose 2. So all you have to do is do 5 times 4. I don't do 5 times 2 because I'm not doing 2. I'm doing the next number down, which is 4, and 5 times 4 is 20. I have 2 spots to fill. 1, 2. That's where the 2 comes in, is how many places you need to fill. So now 5 permutations of 3, I would have 3 spots, so 1, 2, 3, and I start my first spot at 5, and then I do 4, and then I do 3. And then I multiply. So 5 times 4 is 20, times 3 is 60. All right, now I have combinations. Now combinations are an arrangement in which order does not matter. So there's usually less because order doesn't matter, but I want to make sure they're all represented. So here's how this works. A combination, you have to divide the top permutation. You do exactly what we just did, and then you divide it by the number of chosen things at a time. So here's how it works. You have 5 choices of sandwich fillings. How many different sandwiches could you make by choosing 3 of the 5 fillings? So I have this big C and I have a 5 and a 3. So what you're going to do is you're going to do 5. I start with 5 right there. 5 times 4 times 3 goes on the top. On the bottom, you're going to start with however many you chose. I'm going to choose 3. I start with 3, and then I have to have as many numbers down at the bottom as I have at the top. So notice I have these line up, and these line up. You have to have the same on the top as the same on the bottom. You're dividing by the total number of choices. So 5 times 4 is 20, times 3 is 60, and then 3 times 2 is 6, times 1 is 6. So that's 60 over 6, which is 10. So here's another couple examples. Okay, here's how you do it. 8 combinations of 2. So that means I'm going to do 8p2, and then I'm going to do 2p2. So 8p2 would be 8 permutations twice. So I'm just going to do 2 spaces. So 8 times 7. And then 2, I'm going to do 2 spaces, which is 2 times 1. 8 times 7 is 56. Divided by 2 is 28. So I would have 28 combinations. Now this one, I'm going to do 8 permutations of 3 divided by 3 permutations of 3. So 8, and I'm going to fill in 3 spaces, 8 times 7 times 6. And I'm going to divide that by 3 times 2 times 1. Notice, this had 2 at the top and 2 at the bottom. This has 3 at the top and 3 at the bottom. You have to have the same amount on the top and bottom in both instances. So this equals 336 divided by 6, which equals 56. And that's it for permutations and combinations.